Okay, so we're going to have a look at these chemical forensics problem solving 1. The first question was describe briefly how you would carry out a flame test. So, which ions can be identified this way? Make sure you read the full question, because quite a few of you when you were doing this missed out that second part about which ions can be identified. There were 4 marks here. The first mark was for making sure that you mentioned, I'm just going to give myself a bit more space, was for making sure that you mentioned that you would have to use the nichrome wire, and then you have to make sure that you use a Bunsen flame. Okay. And another thing that a lot of you missed out was saying that then you see a colour. You see a colour in the flame, because it's that colour, the difference in colour, that enables you to actually identify the different substances. And so that second part of the question said, which ions can be identified this way? Some of you just said cations, but not all cations could be identified, and some of you listed the ones that you need to know. The ones that you need to know are the calcium ion, and you need to know the potassium ion, and the sodium ion, and there's one more, but I can't remember what it is, so you'll have to look it up in your notes. I tried to be able to get that to come up on the same page, but I can't manage to get it to do it. Okay, so the second question then says, what's the difference between ammonia and the ammonium ion? So ammonia has the formula NH3, it's a molecule, and the ammonium ion has the formula NH4+, it's an ion. There were 2 marks there, I just gave you 1 mark for each of those correct formulae. So how would you test for the ammonium ion? So the ammonium ion, there's 2 different parts to the test, and some of you got the test for ammonium confused with the test for ammonia. When you've got ammonium, NH4+, that's when you need to add sodium hydroxide first. I'm not going to have enough space here. Add sodium hydroxide. And you only need to add that sodium hydroxide if you're testing for ammonium, not if you're testing for ammonia. The second part of the test is the same, regardless of whether you're testing for ammonia or ammonium, and that's when you need to add, when you test the gas evolved with damp red litmus. And as you can see, I'm struggling for space, so I'm going to move it over here. And it will turn blue. For many of you though, it was question 3 that was the one that you first started to find difficult. So the table unfortunately hasn't come out very well when I've imported it in to explain everything. But there's supposed to be 3 rows and 4 columns. So we'll try and see if we can squeeze it in here. The important thing that some of you didn't realise, in fact I'm going to move this over here out of the way for a minute, is that a chemical contains a positive ion and a negative ion. So let's take an example of sodium chloride. This has got the Na plus ion in it, and it's got the Cl minus ion in it. So if we want to find out that we've got sodium chloride, we'd have to do 2 different chemical tests. We'd have to do 1 test for the sodium ion. That's when we'd do a flame test, and we'd get our orange flame, which in these notes is called a yellow flame. And then if we were going to want to find out whether or not we had that chloride ion there, then we would have to do a different test. Here we'd have to add our silver nitrate with a bit of nitric acid first, and then we'd expect to see our white precipitate. you don't get ions in isolation. You can't have just a chloride ion on its own or just a sodium ion on its own. You're always testing a compound. And because you're always testing a compound, it means, if we bring this question back in again, move that out of the way, it means that we're going to have two results of two different tests when we're trying to find out what the whole compound is. So if we take first the one they've actually told us, calcium chloride, we're going to need to test for the calcium ion and the chloride ion. So the chloride ion gives us our white precipitate here that I can't fit in, might have to use a text box. And the flame test colour for the calcium is going to be brick red. See if I can move that there, that's a bit more like it. Okay, so if we look at the other ones then, that top one, a cream precipitate, well, a cream precipitate means that we've got bromine, but in a compound it will be called bromide. And then that golden yellow colour, which we usually call orange, tells us that we've got sodium. And so that compound was sodium bromide. See if I can make it a bit smaller. There we go. Okay, whoops, I put it in the wrong place. There we are. So that bottom one, the yellow precipitate and the lilac, that one, the yellow precipitate tells us that we've got iodide, and the lilac flame tells us that we've got potassium. So this one was potassium iodide. Then we just needed to fill in the additional formulae and names. So our calcium chloride goes in the middle here, make it a bit smaller, and then here, whoops, I need to put my text box back in, here the formula of our cream precipitate and golden yellow sodium bromide is NaBr. I don't know how to get rid of that now. Oh yeah, there we go. Whoops, so I'm moving everything around. There's definitely some disadvantages to this. You'll have to excuse the fact that's now in the wrong place. And that last one was potassium, and it must have been iodide. Whoops, so I was supposed to be writing, wasn't I? Ki. This is not proving as simple as I hoped. Oops, and it's decided to spell check that to Chi. Really helpful. That's supposed to say Ki. Let me just see if I can change it. Nope. So you'll just have to believe me that that says Ki, not Chi. Anyway, moving on. Oh dear, I can't get rid of these. They're all in the way. I think I'll just move this down here. I've now got lots and lots and lots of little things in the way. Right, question 4. Okay, so now we've got when dilute hydrochloric acid was added to solid P, fizzing was seen. This gas turned lime water cloudy. Okay, so if we get lime water turning cloudy, it means we've got carbon dioxide. Which of the ions that we know about gives us carbon dioxide? Well, that tells us that we must have a carbonate ion. Sorry about the writing. Carbonate ion. So carry on reading through. A lilac flame. A lilac flame in a flame test tells us that we've got a potassium ion. So this is telling us that we must have potassium carbonate. So the gas that was given off, we've already said that's carbon dioxide. Okay, and name and give your formula of substance P. So substance P is potassium carbonate. There we go. And its formula is K2SO4. 2CO3. Remembering that potassium forms 1+ ions and the carbonate ion is a 2- ion. That's K+, and CO3 2-, if you can't tell from my writing. Finally, in this video, because I'll do page 2 in a separate one, question 5, some sodium hydroxide was added to a solution of substance S. No precipitate formed, so the mixture was warmed, and the gas that was formed turned red litmus paper blue. So we've seen this earlier on. Red litmus paper blue, gas, and sodium hydroxide. They're all telling us that we've got the ammonium ion, NH4+. But what about the other ion? That's our positive ion. But what about the negative ion that's in this compound? So then we've added some dilute nitric acid, followed by some silver nitrate solution. And we've seen a yellow precipitate. Silver nitrate, yellow precipitate, that tells us we've got an iodide ion, I-. So, give the name and give the formula of substance S. So substance S is ammonium iodide, and its formula is NH4. Oops. I'm afraid I don't know how to do subscript on this. I'm sure it's possible. And then I. Okay, and give the name of the yellow precipitate formed. The yellow precipitate was formed with silver nitrate. So you might remember that your Ag+ ions react with your I- ions to give you AgI. So the name of the yellow precipitate, there's its formula, but it was asking for the name, so it's silver iodide. Okay, that's the end of page 1. That's taken 12 minutes, so you might want a break before you watch page 2.